All right, guys, short one today. We're going to talk about machines a little bit. So, we've talked about work and power, and now we're going to talk about ways that we make work easier, which is through machines. I am going to have a lab for you guys to hopefully be able to do at home, probably next time. And again, today's going to be a pretty short lecture. I don't want to go through the whole thing necessarily with you today. We're probably going to get through, I think, all the material that I want to get through for this year within the next couple weeks. We only got, I don't know if you guys realize. By the way, May the 4th be with you. It is National Force Day, so but I don't know if you guys realize, but it is May the 4th. Okay, May the 4th be with you. I'll say it again. And you guys, I think we're out of here. I think that the last projected school date is the 15th, if I'm not mistaken. Don't quote me on it. Check to see what communications you've had from Mr. Slaughter to kind of confirm that. But we only have a couple more weeks of school left. It's crazy. It is crazy how quick it has gone. Man, I miss you guys. I really do. I hope that you miss school to a certain degree. I hope that you're enjoying this time with family and friends. I really do. I hope that here, as we see other states open up, like Missouri, some of our Missouri friends, some of the Missouri people that go to this school, they come today, right now. They could go to a movie theater, they could go get their hair cut, they could go out to dinner, all those good things. We can't still. I don't know why that is, but I don't want to get political with you guys. I just know that we are still kind of in the midst of this coronavirus thing, and I just pray that everyone is doing okay, that everyone is staying healthy, and that you guys are enjoying. I told my wife this the other day. This is story time apparently. I said, I know you guys are like, why are we listening to him talk like this? But I told my wife, just you would love it if we were in class. You would love it. I told my wife just the other day, this is the most I've ever enjoyed spring in my life. And it's because I've had the time to do it. I went swimming yesterday. It was freezing cold, but I went swimming yesterday for the first time this season, or this swimming season, if you will. But we've had the time to be able to kind of, go outside and take walks and, do things around the house, like garden and stuff like that, I've never been able to do, at least not to this extent before. And I guess that's one of the small benefits to being at home more and not having, in my case work, but in you guys' case school kind of as much in as much force, not as much with sports. And again, I know some of you guys are probably really missing sports. I'm so sad for those, if you guys played softball or ran track. I'm sorry. I'm sorry that got taken away from you this year. I never had that happen when I was in school for an entire season. You guys only get 4 of them for an entire season to go. I mean, unless you guys go on in college, but still, for most of you, you only get 4. So I'm sorry. I'm sorry that's happened. But I hope that you guys have really enjoyed the time that you've been able to have with family and friends. I feel like I should have turned. You guys could have seen my ugly mug while I gave you this little monologue. But I really do. I hope that you've enjoyed the spring thus far. And I hope, I know I won't see you this year, but I look forward to seeing you guys next year and maybe even during summer PE, for some, well, I guess most of you guys already did that, but for the upcoming group, I guess I'll see them there. All right, well, let's go ahead and pray, kind of in light of that. And then we'll talk about how work is easier with machines just a little bit, and then we'll close it up for today. Lord God, I just ask that you be with this group as they continue to isolate in some degree, as some of them actually go out into the world and get to enjoy, God, go see a movie. I can't wait to do that, Lord. I really cannot. Lord, I just pray that I hope that we're not doing that too soon. I hope that we're not staying inside in vain. I hope that whatever the decision, Lord, that our leaders have put into place, Lord, that is God-driven. That it's not something that they have come up with on their own, Lord, but they have prayed and sought your counsel to better understand the position that they are in, and they have submitted, Lord, their authority to you. Lord, I pray that we do that in our lives every day. In Jesus' name I pray. Amen. All right. So, enough of the soapbox. Let's talk briefly. Like I said, I want to go 15 minutes today, nothing crazy. Let's talk about machines. I don't know if you guys realize this, but machines are beautiful things. They are amazing things. They have made everything that we do simpler. Okay, and that is something complex, like the computer screen that is enabling me to project this or record this, like what we have right here. These are machines that are much more detailed than those simple machines that we're going to talk about in this chapter, but they make life easier. I don't know what kind of craziness we'd have to come up with if this situation of us being at home and not at school would have occurred outside of the digital age. If this happened 20 years ago when no one had a cell phone, let alone a way to record and upload things onto the quote-unquote internet at the time, I don't know what this would have looked like. It would have been drastically different. But luckily, we live in a time now where we can do this. I can still talk to you guys. I mean, this is amazing. I just told you guys basically a story a little bit. I gave you a little monologue about life. And you're not even here with me, and yet you're able to go and view this. Now, I know some of you aren't going to view this. I really hope that you do, because I think I am going to post a question today about today's lecture, just to give you guys some points for watching it, because I know some people aren't doing that real well. So here in just a little bit, I'll throw a question in and ask you guys something to kind of give you some points for being here. And I appreciate that some of you are here and paying attention. But machines make life easier because they take away work. Remember, work is a force applied over a distance. If we can make that force smaller, that means that we've done less work. And that's really important. It's nice. It enables us to do things that we weren't able to do before. So I want to show you, this is kind of like our science starter today, because this is actually the use of a lever. I don't know if you guys know, but your arm is a lever. And it enables us to do work and do work easier than we would if it wasn't a lever. And it also enables us to throw a baseball really, really fast. And up there on the mound, we have a 6 foot, I think he's 6'9", giant Randy Johnson, one of the best pitchers, major league pitchers the world has ever seen. I'm not like a super fan or anything, but this is a cool little situation that happened during his tenure. I think it's going to start here. Give it a moment. There we go. So he's about to throw his pitch. Boom! A bird got in the way. We're going to slow it down, I think, a little bit. It's old footage. Sorry, video quality really didn't go up until recently. Boom! Just nailed that bird. You can see it kind of go off in the distance there. There's the bird falling. There's the ball. That was just wrong place at the wrong time, unfortunately, for the bird. He did die, sadly. But I show you this, guys, because I want to show you the power of your arm, the power of the lever that is your arm. Hopefully, you don't use that power for evil, like to kill birds, but I don't think Randy meant to do that. I really don't. All right, so let's see if I can. It's hard to do stuff upside down, really. Apparently. There we go. Oh my gosh. Okay. Sorry about that. Wow. So a machine is a device that changes a force. You could argue as well that a machine is a device that makes work easier for the person. So when using a jack, and no, we're not talking about like jack as in the person. We're talking about a car jack. This is that object that you put underneath your vehicle. I realize some of you guys have never changed a tire, but you put it underneath your vehicle and you push it down. You actually push down a lever, and that changes the force to lift up the car. A jack is almost a perfect example of a machine because it makes work easier. It would be really hard for me to go up to my car. Okay, I don't have a particularly large car, but for me to go up to it and to lift it up with my bare hands. I'm going to go out on a limb here and say that I couldn't do it. It wouldn't only be really hard, it would be impossible. There's no way that I could accomplish that. However, with a jack, it's relatively easy. And what a jack does is it makes the distance that you are traveling much, much, much larger, but that means that the force that is required for it is much, much, much smaller. Let me go get, I steal all my pens, unfortunately. Ooh. I don't even know if I have it. So let's look, if I can find a pen here, something to write with. Here we go. Whew, running out. Let's look at the formula for work, and then we'll kind of understand this. Work equals force times distance. So if you want to make work smaller, it's a horrible arrow. If you want to make work smaller, you have to make either one of these smaller. Okay? So it doesn't matter which one you make smaller, but one of them has to be smaller in order to make work easier. Or you can manipulate that. If you want to do the same amount of work, see, I can't really make the work smaller. Okay? You know what I mean? Like if I wanted to lift up my car, if I wanted to do it with my bare hands, or if I wanted to do it with a jack, it's the same amount of work. I have to lift my car, which weighs a certain amount, up a certain distance. So the work's never going to change. Okay? The outcome is never going to change. Let's say the car weighs 2,000 pounds. You have to lift it up a foot. Regardless of what you do, you're still going to lift 2,000 pounds up a foot. Doesn't matter how you do it. If you do it with your bare hands or if you do it with the jack, the amount of work stays the same. So what I can do then, if this is going to stay solid, we'll put a box around it and say it's not moving. Okay? What I can do is I want to make the force easier because I can't generate enough force to lift up the car. I can't do it. I'm not strong enough. So what I can do instead is I can increase this, the distance, and thus decrease this. And if I increase it and decrease it at the same ratio, the amount of work will stay the same. I'll get the same job accomplished. Okay? So what do I do with the jack? Well, I don't know if you guys have ever used the jack. Again, I don't know if anybody's ever changed a flat tire. But do you just, like, when you have a jack, do you just, like, push on that handle one time? I'm waiting. This is when I would wait for you guys to answer. I hope you all are collectively yelling at the screen on your computer right now. No, you lift it 100 times. Absolutely. You have to continually just push that jack up. I don't know how many times. It depends on the jack. It depends on the ratio that it uses. But it might be 50 times. It might be 100 times that you are moving that handle up and down. That means that you're moving that handle. You're putting a force on that handle, and you're moving it a distance, a really long distance. So one swipe of that handle is pretty much how high up you want the car to go. But you have to do it 100 times. So that means that the distance goes up, but to get the same amount of work, that means the force can go down. So every time you push that handle down, you're not generating nearly as much force as what would be required to move the car, but because you are changing the distance and creating a lot more distance, the force can go down and you still get the same amount of work. I hope that makes sense. Okay, I hope that makes sense to you. The jack changes this force. Not only does a machine sometimes change the way that a force is applied by changing the distance sometimes, but it also sometimes changes the direction of the force. That's a cool thing about a machine too. So when I take that jack handle and I push it down, what happens to the car? The car goes up. It changes the direction of my force. And oftentimes a machine will do that. Okay, so machines make work easier by doing one of these three things, or sometimes a combination of multiple. They change the size of the force needed, okay, which a jack does, changes the direction of the force, which a jack does, and the distance over which a force acts. A jack goes a lot longer distance so that it has less of a force. So a jack actually will do all three of these things. So is the jack a machine? Absolutely. All right. So it says each rotation of a jack handle applies a small force over a larger distance. Again, as you force that thing down, you're moving the jack probably 2 feet. The sweep of the jack from here, I need to bring a jack in, I really do. From here, if you push that handle all the way down, you're moving that jack a very large distance. However, the jack itself, the little plate that the car rests on, it only goes up like an inch. Probably less than that. It probably only goes up like a half an inch. I don't have a jack. I've only used one a couple times. But a small force exerted over a long distance becomes a large force exerted over a short distance. This is truly important. Okay? Understand this. A small force exerted over a large distance can become, if you change it a little bit, it becomes a large force exerted over a short distance. So think about the jack again. again, I'm going to bring one in next year. Going to bring one in. As I force the jack down, I am generating a very short force, or a very easy force. Simple. It's not hard. But I'm doing it over a long distance. But over time, that force changes into a very strong force because it's a force great enough to lift up a car over a very short distance. I'm trying to lift the car up maybe 5 inches off the ground. Okay? I mean, and that's the car's up, but the tire's usually the tire might only be an inch off the ground. Okay? So I'm trying to lift a car basically an inch off the ground, and it might take 100 sweeps of that tool in order to get that to move, just 1 inch. Okay, but it takes a lot of force to move that really small distance when it comes to a car. So instead, I'm doing a small force over a large distance to make up for it. All right. Using a machine to increase force is similar to lifting a stack of books by picking them one at a time. Lifting the books one at a time takes less force, but you must travel a greater distance. So I always like this analogy because you guys can probably relate to it better than the jack. But let's say I had 100 of these guys. You guys are sitting there going, what is this? This is a physical book. It's a solid book that it's not digital. I guess for you guys it'd be like 100 Chromebooks is a better example. But there was a time where every student got one of these, okay? Back in the day, which meant that a lot of times I had to move books from one place to another. I'd collect them from students, and I had to around this time, I'd be collecting books, and I'd have to put them in different places. So I had a choice to make every time I did this. I could either take one book at a time and cover that distance. Let's say I wanted to take them from my desk and put them on the back counter, which was a fairly normal occurrence. I could take one book at a time and move them over to the back counter. Or I could take the whole stack. I could take like 20 books and hold them kind of on my chest in an awkward way and waddle them over to the counter. Now, there's benefits and downsides to that situation. The one book at a time, it takes a lot more time. Okay, I have to travel a much greater distance by walking back and forth from my desk to the little shelf that I'm putting them on. However, it doesn't take a lot of force. Okay, one book is easy to carry. This book probably weighs like, 2-3 kilos. Okay, no, not 3. 2 kilos, we'll say. Probably about 4 pounds, 4.5 pounds. All right, so I could move this book over there. I could do that 100 times. It's not going to wear me out. But if I was moving 20 books, would that be a lot of effort? Would that be a lot of work? Absolutely. I'm moving a much greater mass over, and that requires a greater force over a pretty good distance from my desk to the counter. It's a big room. So you have a choice. You could either exert that force one time and travel a much smaller distance, or exert it over a much larger distance, but exert a lot less force. Okay? So if a machine increases the distance over which you exert a force, then it decreases the amount of force that you need to exert. So if I take these books one at a time, it doesn't take a lot of force for me to do it, but it takes a lot more time to accomplish the same tasks. So some machines can also change directions. The force is applied. Some machines do this, some others don't. Again, a jack does that. Where you push down, it pushes up. A pulley is a good example of that as well. If you guys don't know what a pulley is, we're going to talk about it. It's basically a wheel and axle that you put a rope on. But if I had a pulley right here, and I wanted to lift up this chair is actually, believe it or not, really heavy. It's a solid, I'd say, probably 50 pounds. If I wanted to lift that up, I could tie a rope to it, and if I put it on a pulley, if I pulled the rope down, what would happen to the chair that's tied to the rope on the other side? It would lift up. Okay, so I'm pulling down, the chair would lift up. It's changing the direction of that force, and sometimes that's really valuable. Okay, I have been super tempted. I haven't done it yet, but I think I'm going to at some point soon because my kids just keep getting more and more stuff, like big things that are annoying and silly. Remote control, or not remote control, but those cars that they sit in, that they're electric little cars that they drive around in. Those things are huge. They take up way too much room in the garage. I haven't bought one yet for my kids. They have like the little 4-wheeler one, little cheap one from Walmart, but they want like the 2-seater, the giant like army Jeep thing, and I'll be honest, I don't want it. I don't want it in my garage because it's going to take up a ton of space. And I'm like, what can I do with it? And the only thing that I can think is that I have all this, I have a pretty big garage. And I have all this space up on the ceiling that I don't use for anything. It's a really tall garage. It's like probably 12-foot ceilings at least. Probably more like 15-foot ceilings. So I could create a pulley system where I could literally store all these big things up on the ceiling, and then when I want to get them down, I just undo the rope, and then I let them back down with a pulley system. And pulleys are really interesting. We're going to talk about why they're so interesting here in a little bit, but one of the things that they can do is they change the direction of the force. So as I pull down on a pulley, again, it's going to lift that car up if I choose to do that. Machines can also change the amount of force and direction the force acts through as well as the direction of the force. So we kind of talked about that. I think we're going to stop here. If you want to get this down, that's fine. This talks about a row machine and or a rower and how you move through water. And we're going to talk about that, and that's moving directions as well. You know what? This kind of goes with the same thing. No, we'll save this. We'll still save it because we're already at 20 minutes, which is way longer than I wanted to go. But we'll save this for next time. If you want to get it down, you can. Thank you guys for being. Oh, I forgot the question. Let's see. What month is my wife's birthday? That would be August. What month is my wife's birthday? That would be August. Please put down August on a separate sheet and upload it to the question for this particular. I'll have an assignment that says like today's lecture, and you'll upload August to that. All right. Talk to you guys next time.